trying to get different totals for the rows and columns in this 3 by 3 grid and use the smallest number of counters. So I think a good idea is just to start off by, filling the grid. The ultimate goal would be to obtain 0, 1, 2, 3, 4, and 5, by the way, because that is that's the smallest it could be if they have to all be different. We'll come back to that in a minute. But I guess it gives a bit of insight into what we might first try. So I could maybe try putting 0 in all of one column to get 0. And then I could put 0 in two of them, but I can't then put another 0 in because it has to be different. So I'll go with the next smallest possibility, so just 1. And then over here, for example, I'm going to have to put in a number bigger than 1. So I've got 2. If I put 2 here, then I can get 3. And then finally, what could I put here? Well, I'm going to have to put 4 to get 4 here and 8 here. So that is achievable. And in total, I've used 9 counters. The question is, can we do any better? So I then decided to draw some other grids when I was doing this question. In fact, I then drew one where it got worse. I just did 0, 0. I tried to put a 1 here, and then I put a 1 here. I can't even remember why I did this, to be honest. But the point is, I get 5, 4, 2, 7, 3, 1. I didn't really work out to be very good, 11 counters. But it starts to still give some insight into the question problem, because what we notice is that the number of counters is going to be the total of the columns, but it's also going to be the total of the rows. So all three of these are going to be the same thing. And the same happens over here. We've got 11, and that's 11 here, and 11 here. So let's investigate this and see if we can get any more insight into the question. I could say that the totals, therefore, are T1, T2, and T3 for the rows, and then they have to be different, so T4, T5, T6. And remember, well, what we're trying to do then is minimize T1 plus T2 plus T3, which, by the way, is the same as T4 plus T5 plus T6, along the lines that I was saying before, because we're basically just adding all the counters together, just in different ways. Sorry, that's meant to be an equals. So the smallest possible if I add them all up, would be our 0 plus 1 plus 2 plus 3 plus up to 5. Now this adds to 15. And actually it immediately shows that it's not going to be possible to obtain, because for these two to be the same and add up to 15, they would have to be 7.5. So not possible to split 15 into 2. And therefore, T1 up to T6 equals 16 is the smallest total in theory. Here, we would get T1 plus T2 plus T3 equal to T4 plus T5 plus T6 equal to 8. So what I'm saying is that actually 8, I managed to get 9 with my first go. 8 is the smallest theoretical total. So if we can obtain 8, then that is actually going to be our answer. By the way, if you did manage to obtain 8 right at the start, then you still have to show that that is the smallest possible one by showing that Seven's not possible because it has to be, the total has to be 15 or more, and therefore eight is the minimum. Okay, and then let's give it a go then. So we could go with 0, 0, 0, just like before. By the way, I obviously I have done this already. I'm not just doing this for the first time at this point. Now I saw the trouble that I got when I put two zeros in. So at this point, I'm not going to do that because what it meant was I ended up having a large number somewhere else, that 4. So I'm going to put a 1 in here. And then I could put a 1 here as well. So I've got my 1, I've got my 0. Then if I put another 1 here, I'm up to 2. And then I can't put a 1 here, so if I put 2, then I get a 3. And then I've got to have at least 4. So if I put a 3 here, I get 4 and I get 6. Okay, and it was that extra 1, wasn't it? I can't get 0, 1, 2, 3, 4, 5, but I can get 0, 1, 2, 3, 4, 6, which pushes that total up from 15 to 16, and therefore we see that 8 is the minimum number of counters. Yeah, good question. A bit different, tough, but I hope you enjoyed it. Well done.